So here's what some of your problems might look like. Determine if the slopes are parallel, perpendicular, or if they're neither. So we have line AB and line CD. AB goes through these 2 points, and CD goes through these 2 points. So let's see what you can do. Go ahead and pause the video. Let's see if you can find the slope of this one, and let's see if you can find the slope of this one, and we'll compare them and see if they are parallel, perpendicular, or neither. Come on back when you are ready, and we'll go through the problem. Okay, so you guys know that I like those tables. So I'm going to put my 2 lines in the table, so my 2 slopes. So I have 14, 13, and I have negative 11, 0. And over here I have negative 3, 7, and negative 4, negative 5. So here I have a change, it's going down 12. And here I have a change, it's going down 1. So CD has a slope of positive 12. Negative 12 over negative 1 is positive 12. Okay. Then this guy over here, we have he's going down by 13, and over here he's going down by 25. So we have a y of negative 13 and an x of 25. So our slope here is 13 over 25. They definitely are not parallel. They are not even close to being the same. They're not perpendicular because if it was a flip of this one, it would be 1 over 12. If it was the flip of that one, it would be 25 over 13. So this is definitely neither. So that's all for today. I hope you guys have a good time. If you get stuck, you know how to get a hold of me, and we'll see you later. Okay, guys, so we've talked about the positive slope. Now here's the negative slope. It's going downhill. Again, we read it from left to right, so it goes downhill. The third one we're going to talk about is a straight line across. And if you think about the horizon of western Oklahoma, can be very flat out there, so the land has no slope. So when we talk about a flat line or a horizontal line, this is going to be 0 slope. And then our last one can be a little tricky sometimes. So here's our y-axis. Here's our x-axis. So the line itself is going up and down. So if you think about slope formula, rise over run, we definitely have a rise. So if we're going to go up, say, 2 points, but we don't run at all side to side, so we have no run. Now, we cannot divide by 0. There's no way that you can put things in groups of 0. It doesn't work. We don't know how to do it in math. So therefore, this slope is undefined. Okay, so the next thing that we're going to do is we are going to talk about parallel and perpendicular slopes. Parallel slopes are going to have the same slope. So if you have something like m equals 2, then a parallel slope is going to also be m equals 2. Perpendicular slopes, though, are opposite and inverse. So an opposite slope would be a positive and a negative. So if your original slope is, say, positive 2, then your perpendicular slope we know is going to be negative. Inverse means that they are flipped. So if your inverse slope, if your slope is 1/3, then we can flip it over and it's 3 over 1 or just 3. So in this case, if we have a positive 2, we're going to flip that over and your perpendicular slope would be negative 1/2. Opposite and inverse. Opposite means plus and minus. Inverse is the flip.
Hi there, geometry. How are you guys today? So we're going to be looking at lesson 3.3, slope of lines. And a lot of this is going to be review, so we're going to go through it fairly quickly. If you have anything that confuses you, feel free to rewind and watch the video more than once. So let's talk about some vocabulary first. So we have slope.
Slope is just the rate of change.
It's a ratio between the x values and the y values between 2 points on a line. Not a big deal. So the rate of change is just another name for slope. Rate of change and slope are really simultaneous. They're exactly the same thing, just two different names for it. So we're going to talk about two more vocabulary words, and then we're going to move on. So our first one is parallel. The definition for parallel is just two lines
that never intersect.
They're always the same distance apart. So this is not really new stuff, right?
So our last one is perpendicular.
And perpendicular is just two lines
that intersect at 90 degrees.
Okay, so we're going to go back to slope here in just a minute. If you need to pause to get that written down, go ahead. We're gonna go back and talk about slope. So there are three ways to find slope, and it's really dependent on what you need to do with them as to whether or not which one you're going to use.
So there are three ways.
The first way that we're going to talk about is just the change in y, or delta y, over the change in x, or delta x. The triangle means delta. It just means change. So this is really good to use when you have a table. Probably some of the best ways to use it is with a table. So if we have something like this, and we're trying to figure out what the rate of change is, we want to know what the change between x and y is. So with the change of y, we're going from -2 to -6, so we're subtracting 6. The change in x, we're going from 1 to 4, so we're adding 3. So our change is going to be the change in y over the change in x. So our slope here is a -2. That's the first way to find slope. The second way to find slope is one that you should know, and it's rise over run. So this is just when we have a line and you're trying to figure out what the rise is, or how far it goes up, and what the run is, or how far it goes over. This is best used when we're using graphs. So that's when we're going to find slope. So the last one of the three is slope formula. Slope formula is used when you have coordinate pairs. And the slope formula is y2 minus y1 over x2 minus x1. Now, if you have two coordinate pairs like 3, 2, and 6, 8, it doesn't matter which one you call x1 and which one you call x2. Same thing with y1 and y2. It doesn't matter as long as they're the same coordinate pair. So if I make this pair 1 and I make this pair 2, then this would be x1 and this would be y1 and this would be x2 and this would be y2. So then we're just going to plug them into the equation. Now, I'm a big fan of taking out variables and putting in parentheses. I've seen all too many times middle school kids lose negatives a lot. They lose them a lot. And it's because we're not putting parentheses where they belong. And we don't have any negatives here, so it's not a big deal. But let's go ahead and put them where they belong. So y2 is 8, and y1 is 2, x2 is 6, and x1 is 3. So now we just work it out. So we've got 8 minus 2, which is 6, and 6 minus 3, which is 3. So our slope here is a positive 2. Okay, so now I want you to try finding slope. You can choose which way you want to do it. It doesn't make any difference to me which way you choose, but we're going to do a few examples. So you're going to find slope when you have the coordinate pairs negative 5, 1 and negative 2, negative 2. So I want you to go ahead and pause the video, work this out and find the slope, and when you come back, then you can start the video again and see if you got it right. Okay, so let's check it out and see what you got. So if I'm going to do y1, or y2, sorry, minus y1 over x2 minus x1. Now, you may have flip-flopped these and made 1, 2, and 2, 1, and that's okay. It really doesn't matter. It doesn't matter which one is 1 and which one is 2. It's going to come out the same way either time. So we're going to make that a plus, and we're going to make that a plus. So we have 3 on top and negative 3 on bottom. So our slope here is a negative 1. How did you do? Let's try one more. So if we have 6, 0, and 4, negative 2, this time I'm going to do this using a table. So I'm just going to make myself an XY table. And I'm going to find the change in Y, which is going down 2, and I'm going to find the change in X, which is going down 2 as well. So the change in Y over the change in X, negative 2 divided by negative 2 is a positive 1 slope. So just to review what slope looks like, there are 4 different kinds of slope, okay? The first kind of slope is a positive slope. It is going from the left to the right, and it's going up from the left to the right. We always read slope going up, or going from left to right. So this is a positive slope. Okay. Our second one, when you're reading from left to right, goes downhill. So reading moving from left to right, it's going downhill.